All right, Algebra 2, we're almost to the end of the semester, but before we get all the way through, I want to take just a few sections throughout the year and just kind of go over a few things because I feel like they're really important. So the first section that we're going to talk about is linear functions. This was like way back in chapter 1, but I want to review it just so that you kind of have it solid in your brain. You should have a sheet in your packet that looks like this. If not, I'll have it attached to Google Classroom so that you can access this document. But this just kind of gives us a brief rundown of what linear functions are. So you should know by now that linear functions, when you graph them, look like a line. Okay. So what we want to do in this top part, and I'm going to go through number 2 with you, is we want to first make sure that this equation is in slope-intercept form. Slope-intercept, okay? The slope is going to be the m. So if I write this in terms of y equals mx plus b, that's slope-intercept form. The m is going to be the slope, the b is going to be the y-intercept, okay? So this is slope, this is y-intercept. Okay, so I want to make sure that it's in that form to start with, okay? And then to graph from there, it's really easy. Once he's in y equals mx plus b form, I start with the y-intercept, and y-intercept is where he intersects the y-axis. So he's intersecting at 2. I don't know if you can see these lines very well. 1, 2. So I put a dot on 2, and then the slope, since it's negative, this means I can go down 3, down 1, 2, 3, and I'm going to go to the right 1, 2, 3, 4, okay, and put another dot. And then I'm going to connect my lines, or I could go another down 3 and over 4, okay, but I'm going to connect my lines, or my dots, and that's what my linear function is going to look like, okay. I have a lot of people, though, that do this incorrectly, who start up here at 2 and they'll go down 3 and this way 4, okay. If I would do that, I would end up, don't draw this on your sheet, I would end up with a line that's going uphill, okay? And my slope is negative, so I want to make sure that my slope is going downhill so it looks like that, okay? Now, what do you do, like on number 5, when you're not in slope-intercept form? Well, we just basically have to solve for y. We have to get y by itself, okay? So the first thing that I'm going to move is I'm going to subtract the 3x to the other side, okay? So I'll have 3y is equal to, and I like to write the x first instead of the 12. I cannot add the 12 and the x together because the 12 doesn't have an x behind it. So I would write 3x plus 12. And then I still don't have y by itself. I need to divide by 3 for every piece. Okay, divide by 3, divide by 3, divide by 3. So y is going to be equal to negative 3 divided by 3 is going to be negative x. 12 divided by 3 is 4. Okay, so to graph this, I'm going to start at positive 4. So I go up to 4. And then the slope is negative x, which is like negative 1 over 1. So I'm going to go down 1 to the right 1, down 1 to the right 1. I'm sloping downhill if I do that. Okay, connect all my dots, and this is what negative x plus 4 is going to look like. All right, so this should be all just review to you, hopefully. Hopefully I'm going too slow for you because this is all stuff that we've done before, okay? All right, so now we move on to writing the equations. So let's say I know my slope is 2/3, and I know that a point that's on my line is negative 1, comma 4, okay? So we want to write this in slope-intercept form, y equals mx plus b, okay? Where m is the slope and b is the y-intercept. So if they tell me that my slope is 2/3, I'm just going to plop him in for that m there. So now I have y equals 2/3 x plus b, okay? And then the only thing I need to find now is b. Well, how do I find b? I've got to use this other piece of information to find b. And so I'm going to plug negative 1 in for x and 4 in for y to solve for b. So 4 goes here. Negative 1 goes here. Don't put them the other way around. Even though the negative 1 comes first, that goes in for x, not for y. Okay? 2/3 times negative 1 is going to be a negative 2/3. Okay? And then to get b by itself, I'm going to add that 2/3 to the other side. Okay? 4 plus 2/3, I'm just going to write as 4 and 2/3. So 4 and 2/3 is what my b value is. Okay? But then I don't stop there. I rewrite the whole thing, leaving y and x in there. So y equals 2/3 x plus 4 and 2/3. Okay? And that is as easy as it gets. Okay? Even though they're kind of ugly fractions, but that's slope, and then I use the point to solve for b, okay? All right, on to the back side. Let's do a couple of these. So now they make it a little bit harder for us. Write the slope-intercept form. So we need y equals mx plus b. And they give us 2 points that live on the line. Okay, great. Now I still want to plop m in there first. I want to plop my slope in there first, except they don't tell me what the slope is like they did in the last problem. So I have to use these 2 points to find the slope. Okay, so slope is rise over run, or the formula for slope is the y's, y2 minus y1, because the y is the rise, okay? The runs are x2 minus x1, okay? So those are my run values. So rise values, run values. I'm going to do y2 minus y1 over x2 minus x1, okay? And I use these, this would be x1, y1, x2, y2. My second set of x's and y's, my first set of x's and y's. All right, so to solve for m, I'm going to do my second y coordinate is 2. First y coordinate is 5. So 2 minus 5. Then I'm going to do second x coordinate is negative 6 minus 3. So 2 minus 5 is negative 3. Negative 6 minus 3 is negative 9. Okay. Since they're both negative, I can cross those out and make those both positive now. And 3 over 9 is 1/3. Okay. Now I'm at the same step that I was in the previous problem. So I know that the slope is 1/3. And then I actually have 2 points, and I can choose which 2 points, or which one of those 2 points I can plug in. So I'm going to plot my 1/3 in for this m. Okay, y equals 1/3, x plus b, and I need to plop numbers now in for x and y to solve for that b. So I don't like dealing with negatives a whole lot, so I'm going to put in 3 and 5. Let's put those guys in there. Okay, so 5 again goes for y, and 3 goes in for x. Okay, all right, so try to get used to your fractions here. 1/3 of 3, or if you want to think about it as a fraction, it's 1/3 times 3 over 1. 1/3 of 3 is just going to cross out and be 1. 1/3 of 3 is 1. Okay, then to get b by itself, I have to subtract that 1 to the other side. So b in this case is going to be 4. Okay, last thing I do is write it all together. So y equals, my m was 1/3, x plus 4 is my b, and there is my linear function that goes through those 2 points. Okay, all right, a couple more. Write the slope-intercept form of the equation that fits the condition, then graph the line on a coordinate plane. Okay, so let's see what this looks like. We have a line. They give us the equation of a line, and I want something that is parallel to this line. Okay, so one thing that I know about parallel lines equal same slope. Okay, they're going to slope at exactly the same degree. So if I have 2 lines that are parallel, the rise over the run here is going to be the same as the rise over the run here. Okay, so what is this guy's rise over run, or what is his slope? Okay, well, his slope is negative 2/3. Okay, so I know that my new equation, y equals mx plus b, the m has to be negative 2/3. And from there, I just need to figure out where b is. Okay, well, what do I do with this 3? I haven't used the 3 yet, right? Negative 2/3 was my slope. What do I do with the 3? Okay, this is where you cross that 3 out. Then you never use that last digit, because they're going to have a different y-intercept. So how do I figure out what this b is? I'm going to plug my points in, just like we did in the last 2 problems. Okay, I'm going to plug those points in. So I plug 4 in for y, and 0 in for x, and that makes it really nice. Because what's negative 2/3 times 0? That goes away, it's 0. So b, in this case, is just going to be 4. And then I rewrite, and I say y equals negative 2/3 was my slope, x plus 4, and there is my function. Okay, so if we want to graph this, I'm going to run into the next problem over here, sorry. If I graph the first one was plus 3, right? And then I'm going to go down to over 3. 1, 2, 3. This is going to be the original equation. Okay? But then if I graph the second one, here I'm starting at a positive 4 instead of 3. So I'm starting here at positive 4, but I'm still going down to over 4. Right? And he looks like that line. And those 2 lines are parallel to each other. Okay? Because they have the same slope. All right, last one. Let's look at perpendicular lines. Okay? So I have this guy right here. And perpendicular lines, so I'm going to write this over here to the side. Perp line. What is true about perpendicular lines? Their slopes are negative reciprocals, okay? Negative reciprocal means you flip it and you make it negative. If it's already negative, you make it positive, okay? So like 3/4, his negative reciprocal would become negative 4/3. 1/7 would become negative 7/1, or just negative 7. Okay, so those are some examples. Now, this guy's slope right here in this equation is 2, okay? And so what will the negative reciprocal of 2 be? Okay, the negative reciprocal is going to be negative 1/2. This is like 2/1, so to flip it, negative 1/2. Okay, and it passes through the point negative 2, 0. So I want to do y equals negative 1/2 x plus b, and I'm going to plug these guys in and solve for b. So negative 2 is my x, 0 is my y. Make sure you put those in the right spots, otherwise you're going to get a wrong answer. Negative 1/2 times negative 2 plus b. Okay, now, what is negative 1/2 times negative 2? Well, I know the two negatives are going to become positive. So what's half of 2? Well, just think about what is half of 2, right? Anytime you have a fraction, those two are reciprocals of one another. So they're going to cancel out and they're going to become 1. Half of 2 is 1. And so then to get b by itself, I'm going to subtract that 1 over. So b is going to be negative 1. Okay? So then I have y equals negative 1/2 x minus 1, or plus a negative 1, you can write it as. Okay? If I graph those guys, let's start with the original. The original was, again, if you want to cross out that negative 4, because we never use him ever to find our new equation of our perpendicular line, make sure that when they're asking for parallel or perpendicular, you're only ever looking at the slope. Okay? So this one, if we graph him, he starts at negative 4. So we put a dot, and then 2 as a fraction would be up 2 over 1, and that's going to be our original line. That's where we're going to start. Okay. The second line then that we're going to do here, this one we start at negative 1 and put a dot, and then from there we go down 1 over 2, down 1 over 2, etc., and I keep going. And he looks like this. Now, are those two guys perpendicular to each other? Perpendicular means they meet at a 90-degree angle, and that looks like a pretty good 90-degree angle to me. So yes, we did that right. Okay, all right, so hopefully all of this was review. I kind of went through it really fast. This is stuff that you really, really, really need to know, and you need to know how to do this. I can't tell you how many questions they ask on ACT, on standard math tests about this stuff. So this is superly important.